Alright, now I'm going to talk about dam safety in general, and then I'm going to talk specifics about the Oroville Dam. And the reason I'm doing this is because I see a lot of disinformation disseminated on both sides of this issue. And to explain myself, there are two sides of this issue. There should not be. The first side of the issue is there's nothing to worry about. There's nothing wrong. Everything's going great. Just relax and don't ask us any questions. That's wrong. The other side of the issue is run for your lives. All hell's about to break loose. And that's wrong too. So, as is not always the case, but is sometimes the case, probably the truth somewhere in the middle with Oroville Dam. And Oroville Dam it's a study in dam safety. And it is a study in the failure of dam safety and of the stewardship of infrastructure, which the entirety of the United States is guilty of, a failure of the stewardship of infrastructure. But it manifests no more clearly than it does at Oroville Dam. Oroville Dam is an earthen embankment dam in Oroville, California, northern part of California. It has a total height from the plunge pool to its maximum elevation of 770 feet, making it the highest dam in the United States of America. That is significant because the higher a dam is, the greater the pressure becomes at depth, and the greater the pressure, therefore, pushing against the dam to induce rotational or sliding failures of the embankment of the dam itself. I'm going to sketch Oroville Dam, and I'm going to tell you what I believe is happening within the dam that is of concern, and probably what's not happening within the dam. Oroville Dam. And this is obviously a simplification of the dam. Make it so it fits my chalkboard so the slopes are not accurate, of course. This is 901 feet by memory, is that correct?
It is.
Yes? Okay. 901 feet to the top of this OG weir, which is a concrete structure about 30 feet high, which dictates the maximum elevation of the dam. Beyond 901 feet, water begins spilling over this weir and running downslope toward the Feather River below. The elevation from that 901 to the base of the dam at the plunge pole, which would be probably at the powerhouse, the Feather River elevation very close to that, is 770 feet. Now, besides this OG weir governing structure, there's another structure across that top of that dam also. So this is the dam. Water elevation right now is somewhere in here, and that creates a hydration of the dam. This is called the phreatic surface within the dam. The phreatic surface of a dam, when it's homogeneous materials in construction. This dam is not necessarily homogeneous, so this will alter that somewhat. But the phreatic surface looks like a half a bell curve. Something like that. It starts out pressurization of the aggregate of this water against the dam, permeates water through the dam, and this is without any filter drains or any internal drains. This will create a half of a bell curve structure of phreatic surface within the dam. So these soils in this area are not hydrated soils. These soils in this area are hydrated. The manifestation of this, the distance between the bottom plunge pool here, and any evolution of the phreatic surface from the dam, wet face of the dam downstream, should never exceed 30% of the total dynamic head. So it should be about a third of the way up the dam with all those things I said. Homogeneous substance, no drainage, etc. So with those things it should become less than that 30%, lower down, because the drain structure within here will depress the phreatic surface. So never should we see evolution of hydration, phreatic water moving through the dam above 30% of the total dynamic head. If we see that, that should cause us concern. So if we see a wet spot here, as is happening in the left groin of the Oroville Dam, I'm not going to beat this up any more than I've already made my statement about the green spot, the infamous green spot. This is evolution of water from the reservoir through the dam. It's not a conductance of water from this side of the dam to that side of the dam. This was discussed in the construction documents in detail. Both of the abutting structures, both of the indigenous soils on either side of the Oroville Dam, have canted plains of fractured rock. We've seen a lot of weathering of the rock of the abutting structures. It's been obvious. It washed downstream in the last event to the tune of $1.2 billion. So there's no doubt that this is not high recovery solid rock. There's no doubt about that, because high recovery solid rock does not flow downstream, I think, by definition. So this evolution here and the many others that we see on Oroville Dam are a movement of water through the dam which is not normal phreatic movement. The reasoning for that is they're significantly above that 30%, and the dam does indeed have cutoff wall within it, which is, I think, around 50 feet high, but which was fractured in construction. It has a core, which is a clay-like material. It's actually pretty rotten material for a dam core that they used, but it's the best they had there. And then you have all this abutting soils, which are graded but somewhat homogeneous in their nature. So this should act to drop off the phreatic surface here so that it would be deeper than it normally would. Beyond that, there's a galley within the structure. I'm not sure the location of the galley, and I imagine that gallery has drains around it, and that would further act to drop the phreatic surface low. Normally, on an earthen embankment, well-designed dam, especially a large dam, you would see no manifestation of the phreatic surface at the base of the dam. That would be ideal. Many kind people, and I greatly appreciate it, have sent me much information asking me for my opinion. And I, like everyone, I have an opinion. And I've spent a lot of time around dams and large construction projects. I want to show you Oroville Dam this time from the top, looking down on it. So this is the crest of the dam. This is the O.G. Weir section here. Always looking downstream on a dam, it's toward the right abutment. In fact, there are indigenous soils beneath this O.G. Weirs, and they dive down toward the center of the dam here. And then we have a gate structure, and there are a number of gates here. There are eight gates in Oroville. And they're large gates. We call them radial arm gates or Tainter gates or Trunnion gates. The trunnion being the pin which bears the load induced upon the structure from those gates. So the gates radiate out from these trunnions and stop the water at a point like that. So they hold the water back, and then the sluiceway evolves from that, and we all know about the sluiceway because it is what washed downriver. And the sluiceway on this has training walls on the sides, and it has an under-drain system. On Oroville Dam, what we see that is not normal. First of all, these slabs have construction joints, as they should. You can't pour a homogeneous piece of concrete down a long spillway because it will fracture, because concrete shrinks as it cures. So there are construction joints along the way. And we see an evolution of water from these construction joints. We see water coming out of the construction joints and making the surface of the slabs wet. We also see sections of water where they go into a construction joint and then go away, like this. Where the water is actually running down. There's a break here at about 2,400 feet. Is that right?
3,000. Station 3,000 is the problem.
Okay,
right?
so station 3,000-ish. It breaks over and starts running downhill significantly. And both before and after this, we see these evolutions of water on the spillway. What does that tell us? It tells us that there's water moving through the dam that is pressurizing the area below the spillway. There's a drainage system beneath this spillway that should be picking this water up and conducting it off long before it raises up and comes out through the cracks in that slab. That's not working for some reason, it would appear. The other thing that's happening is that water is running past the gates and running down the spillway, and they're putting these barricades in place and diverting the water to one side or another, and it's spilling down the spillway. And the statement has been made many, many times by DWR and their parrots that this is perfectly normal and the gates were never intended to be watertight. Well, that's an untruth. That's not true. The gates were certainly intended to be watertight. The gates have compressible rubber sill in the bottom of them that the gate sits on, and they have a rubber bulb which extends out against a brass wearing plate on the sides, as do all Tainter gates or radial arm gates, and they're meant to be watertight. Now that doesn't mean you can't have a drip coming through that if a piece of straw gets in that thing. It's not important. So in that way, perhaps that's a partial truth. But when you have significant amounts of water running through the gates, that's not normal. That is not acceptable. And that's misleading to say that that's normal, that that's the way it was designed. It was designed to be a dry spillway so that one could walk down the spillway and inspect it. Instead, of course, we have water leaking through the gates. And we actuated the spillway, they actuated the spillway recently. In April, after they finished the brand new spillway. And then they stopped using the spillway. And before actuation of the spillway, they gave us an elevation at which they were going to relieve the water from beneath the dam. And now they've changed that elevation, and they've said they're going to let the dam go up to within a foot of topping. Now we talked about that 901 foot, so they're going to let the water potentially get up to 900 feet. With a significant wind driving water across the lake, with no precipitation, that'll top the OG weir. The topping of the OG weir, as we already know, causes significant damage downstream because the soils haven't changed. They've just been moved from place to place. You take fractured rock which is not high recovery, and you move it 3 or 4 times and then place it and compact it, you now have less stable rock, not more stable rock. So if the OG weir actuates and water runs downstream, now there's an area of roller compacted concrete here, RCC, beneath the OG weir, and that is tied into a soil mixed wall. Why in God's name? Doesn't matter, but soil mixing is a number of holes bored through the previous hole, which the soil has Portland and water introduced into it to create a cement slurry of soil and Portland, which then hardens by the process of hydration and creates a wall across them. A slurry wall would have been impervious. This is often not perfect and often pervious. If water was still moving through this area, then we would see water coming out potentially on the RCC at these high elevations. We see that. We see water coming up and hydrating the face of the RCC. We see water moving within the emergency spillway. All of these things collectively, everything that's above that line of 30% of the total dynamic head, tells us that water may be moving freely through this structure unimpeded as it should be by the earth within the structure. When we see manifestation at 80%, 70%, 60%, that's concerning. That should be concerning to any dam person. It's concerning to me. That's not what we want. We wish for this to be dry, and then if we end up with an emergence down here at 10 or 15, 20%, then that's okay. As the dam ages, filters become clogged, becomes less efficient. Never, ever, 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 ever should we see soils being moved through these evolutions of water at high elevations. Because as soils move through the structure, taking the fines out within that conduit, whatever it may be through the structure, then it becomes less and less and less stable over time. The gate structure here, I made a lot of noise about 2 years ago. When you read the reports, the maintenance reports on the dam, over and over again they talk about cracks in these structures that hold the trunnions of the gates. That's significant. Also here a binding of the gates against the sides. That's significant. It's not an issue because of the displacement of the gate within the structure so much, but it is a problem because what it speaks to is a transmission of water beneath the structure, which is moving fines, therefore compromising the foundation of this structure itself. To further this concern, when we looked at the dam long ago, we saw a spot a number of people talked about here, that after the water was drawn down remained hydrated, as if water which had moved up and then down was draining back toward the reservoir. This would be indicative potentially of a port. That time I made the statement that I was concerned that perhaps ports may exist. Certainly they exist within the indigenous soils of both the right and left abutment, and that there could be a port which would manifest across this and would compromise the foundation of this structure. And I considered this one of my great concerns when you look at my discussion about failure modes of Oroville Dam. That this structure could be compromised and potentially could fail due to this. Now, of course, we've let the water come up so that all this is filled, and this potential port, we don't know if it is a port or not, has been charged. In other words, pressure has been induced through here. And also, coincidentally, we've seen this manifestation of water downstream. So we've seen potentially a port upstream and potentially a port downstream in a number of areas. A port is not a perfect hole through a dam. And ports exist in many, many dams. They are not necessarily a tragedy in the way. But the water must be stopped from being conducted through an earthen embankment dam, or eventually, over time, that will fail the dam. You cannot plug that water from moving here, and you cannot plug that water from moving here. Neither of those will work. If you plug this evolution, it will simply manifest elsewhere in many, many different ways. This is a myriad. Earth is not solid. Earth is a huge, huge number of fissures and cracks and open voids that communicate water from one side to the other, potentially. When that's happening the way it should, with the fines slowing this evolution, it's phreatic movement. That's no concern. When it happens relatively less impeded by large aggregates of soil, then it begins manifesting higher up than this 30% total dynamic head that we talked about. And that is what we are potentially seeing on Oroville today. So, how do we fix this? First of all, in order to make an effective repair, it is best to reduce the pressure here, which can be significant. So there's a significant force, and we'll call it 50 pounds per square inch here for the sake of conversation, trying to push water through here. In order to push against that, we would have to induce at this point 50 psi to equal it, and then a further pressure to induce them to move toward this way. At some point, these pressures exceed the shear of the soil, and so you blow up an area within the soil, fracturing the soil. That's not acceptable. If you try and move it this way, you can't get the void filled. So moving grout this way requires that we reduce this pressure. There are a number of ways to do that. The easiest one is to reduce the reservoir level. We did that. We had the reservoir down for 2 years. There should have been a grouting program where we capped and ported, and we capped and ported, and we pumped grout through there. And lots of people have different ways of doing this. I like Portland grout, and I like urethane foams, chasing them both before and after the Portland load. So it's filled with Portland, and you're pushing urethane foam. That tends to both adhere the Portland to the soils and to seal those interface areas within the structure of the port as it's moving. I have pumped grout on a dam and watched bubbles come up in a reservoir far out in the water, hundreds or thousands of feet out in the reservoir. Tiny ports that were communicating and moving through that dam. As we pumped all that, urethane was coming up in the reservoir, bubbles were coming up in the reservoir, absolutely assuring us that we were filling a port within the structure in the reservoir floor itself. When I look at Oroville Dam and I try and guess what the greatest concern is, The most probable failure mode. And when I say most probable failure mode, I'm not reflecting an imminent, immediate failure. I'm talking about a methodology for a failure to manifest itself, and there is no time associated with that. But it's a way that a failure could happen, and that is how you address the potential for failure on a dam such as Oroville. In Oroville, as I am describing there, I think the issue that is being faced right now, that is the most serious by far, is a communication between the pressurized pool and the underside of the spillway, previously the spillway, and now the brand new $1.2 billion spillway. I believe that when the gates are open, there is a void that becomes actuated and a communication of pressurized water of the pool with the soils beneath the slab of the spillway. If that is correct, then that could very easily cause a charging of the drainage system, a charging of the area beneath the slab, which is not a desirable situation and which can produce failure, as it did 2 years ago. So that is the greatest concern that I have. I think that a number of things that are occurring, binding of the gates, differential settlement, cracking, a number of those things are indicative of the potential for there existing a port beneath the gate structure which is moving soils. An undesirable thing at its best, and critical because that is the controlling structure for the dam elevation crest at that point. And I think that the junction between the emergency spillway OG weir and the structure of the gate structure itself is the weakest point of that dam at this point. Okay, so I've redrawn my dam again from the crest. And here we have the pool side. And here we have the gate structure. And here we have the OG weir. We were talking about potentially a port. I don't know that this exists. I think it does. And I'm allowed to have an opinion. If Juan Brown's allowed to have an opinion as a professional pilot about a dam, I'm allowed to have an opinion too. Having done this for a quarter of a century exclusively, and for a quarter of a century before that, off and on. I believe that we have ports which come through kind of like this, and I believe that they're causing areas on the spillway here that are hydrated, and I believe they're migrating beneath the OG weir and causing areas where we saw rills before in the last failure. And I believe that they need grouted properly by someone who knows what they're doing, and there aren't many people that know how to grout properly. And I'm not suggesting that I do it, although I'm willing to help with information. No, thank you. No. But this is what I believe is going on, and this is one of the items that I pointed out years ago when Lisa and I went through failure modes. The other was this wet spot here, the green spot everyone calls it, which is the same thing. It's traveling around through indigenous soils and manifesting up the dam. Now understand, from the side, these ports look like this. Here's the grade going up, there's the dam, there's the grade going down. Everyone pictures a port like this, straight through. It's not. It can go like this. So here's the port, it can go like this. And most often does. At these areas where this port is high, it scours soils and creates a dome, which I call rising dome failures, because these things come up eventually and they show up on the surface as a sinkhole. Everyone calls them sinkhole. And the soils beneath that sinkhole, down to wherever the port was, are not at all properly compacted. It's not a good situation. So we need to be able to push grout through that, the whole way through it, and have it manifest out at the beginning. That is the repair for this situation, if indeed that situation exists. One of the big problems with Oroville, there are many problems with Oroville. It's an older dam, and there are literally tens of thousands of older dams in the United States. Many, many, many. Each state has 4,000, 6,000, 3,000, 2,000, 8,000. All of those dams, as an inventory, are old. They're toward the end of their lives. They were designed for 50 to 100 years. Dams can remain almost indefinitely properly maintained. Oroville, I think, shines as one of the most poorly maintained dams in the United States. Also the tallest dam in the United States. And also one of the most critical dams in the United States. I've seen dams, worked on dams, where honestly, if the dam failed completely, no one would know about it. Up in the middle of the mountains, flood control dams emptying into a river below, it would take days before anyone figured out what happened. This is not that. This is a dam which affects the lives of a lot of people. It's an important dam. It's a high hazard dam. One of the things that concerns me most about the way this is being handled, besides the secrecy, is the malice. The malice toward those who try to find truth. It is not the fault of those who try to reflect truth and falter that they are not given the information. And there's no incumbency on the teller to guess the truth and get it completely right in order to be heard. This is all false narrative. When I look at what I see, I imagine this, but I could be completely wrong. But I have the right to understand. And I have much less right to understand than you do if you live in California. We all have the right to the truth. And that has suffered the most in this entire evolution at Oroville Dam. And it is not over, and it is not all better. When you have Mr. Gallagher and even the police, the sheriff, make statements to you that they've talked to DWR and everything's fine, they're not acting to me like men who believe that everything's fine. They're acting to me like men who acted as they've acted before, in a secret way, shielding truth from people who have reason and desire for truth. And that is the biggest failure of Oroville Dam. It's a shame that you don't have someone who would come out and stand on that dam and say, here's where we stand, and here are a list of the issues that we have yet to address, and here's how we're going to address them. That will never happen there while those same people are in charge of that dam. Thank you very much for hearing me.